This section is on simplifying rational expressions. So rational expressions is an algebraic expression whose numerator and denominator are polynomials. The value of the polynomial in the denominator cannot be 0 since division by 0 is undefined. This means the rational expressions have excluded values. So with this section, we are going to be working with excluded values, which we've worked with in the previous sections. And then we're also going to be looking at polynomials, and we've covered polynomials in previous chapters as well. So let's get started on some examples. The first one says, find any excluded value of each rational expression. So this is kind of going back to the last previous section with working with excluded values. And we are going to be looking at the denominator here for a. We have 12 divided by t plus 5, and we are going to set the denominator equal to 0 and solve for t. So what we do here is we have t plus 5 equals 0. We're then going to subtract 5 to each side, so t is going to equal -5. So my excluded value for a is going to be -5. So this should be a review to you from the previous section. But let's look at b here. What we have is 3b over b squared plus 5b. Again, to find our excluded values, we're going to be looking at the denominator. And we're going to be setting this b squared plus 5b equal to 0. So there we have b squared plus 5b equals 0. Then we're going to look at this and say, is there a variable here that we can pull out? And there is. We can pull out a b here because we have b squared plus 5b. So if we pull out a b, what we have left is, in the parentheses as shown, b plus 5 equals 0. So then we're going to use the zero product property, and we're going to solve for b. So what you're going to do is you're going to set this b outside the parentheses equal to 0, and then you're going to set what's in the parentheses, that b plus 5 equal to 0. So here we have b equals 0, or b plus 5 equals 0. We're going to solve for b here for the second situation by subtracting 5 to both sides. So our excluded values are going to be 0 and -5. So that'll be my answer there for b. Looking at c, we have 3k squared over k squared plus 7k plus 12. Again, we're looking at the denominator. And we are going to set this equal to 0. But look at the denominator here. We have a polynomial. And what we're going to do is we are going to look at factors of k squared plus 7k plus 12 and set that equal to 0. So when we think of factors, we're going to get k plus 5 and k plus 3, because we have to think, what are factors that would give me 12 but add to give me 7 in the middle right here? And that's this k plus 4, k plus 3 equals 0. And then what we're going to do is we're going to set each of these equal to 0. So k plus 4 equals 0 and k plus 3 equals 0. We solve for k. So k is going to equal -4 or -3. So my excluded values for this are going to be -4 and -3. With example number 2, we're going to simplify these rational expressions, and then if possible, we'll see if there's any excluded values. So sometimes you might run into a situation where you don't have excluded values. The first one here, we have 5m squared over 15m. And our first step is we are going to factor 15. So notice we have 5m squared for the numerator. We're going to look at the denominator, that 15m, and we're going to factor that out. And we get 3 times 5m. Then what we're going to do is we are going to divide the common factors. So when we do that, common factors are going to be the 5m. Those are going to be the common factors. Note that if m equals 0, the expression is going to be undefined. So we're now going to simplify this down. And when we simplify this, since we have 5m squared for the numerator, we're left with just 5m, because we factored out 1m and 5, because we have 5m for numerator and denominator, so we're left with m for numerator over 3 for our denominator. And so m cannot equal 0, so that's just my answer here. It's going to be m over 3. And my excluded values here, we just say m cannot equal 0. So this will be my answer. For b, we have 6p to the third plus 12p over p squared plus 2. So what we're going to do here is we're going to factor out the numerator. Now we're going to look at the numerator and we're going to factor that out. So once we factor that out, notice how you have a p for both situations, for both terms, and 6 goes into 6 and 6 also goes into 12. So we can actually pull out a 6p. So what we have left for the numerator is 6p parenthesis p squared plus 2 over p squared plus 2. And then we're going to divide out common factors. Our common factors are going to be this p squared plus 2. So we're going to divide that out. And what we'll be left with then is 6p over 1. And what would be my excluded values? It's just going to be 6p, because 6p divided by 1 just gives me 6p. For c here, we're going to look at 3n over n minus 2. We see if there's anything in common, if we have any common factors, if we can divide out common factors. And in this situation, there is no common factors that we can divide out. So what we do is we just set our denominator equal to 0 to find the excluded values. So it's just going to be 3n over n minus 2, and then you set n minus 2 equal to 0. Add 2 to both sides. And so how did they get n cannot equal 2? Because when you solve this, n equals 2, which means that our excluded value means n cannot equal 2. Something to think about in this section is thinking back on Chapter 8, when we were working with opposite binomials. Opposite binomials can help you factor polynomials. And so what you're doing is recognizing opposite binomials that can help you simplify rational expressions. So in this next example, we're going to run into a situation where we might see opposite binomials. And so we're going to go through an example of that. Consider what you have here. This is an example. We have x minus 3 over 3 minus x. The numerator and denominator are opposite binomials, so therefore, what we do is we can rewrite this as x minus 3 over negative x plus 3. And what we do here is, I don't know if you recall, but from Chapter 8, if we pull out a negative 1, like they show right here, when you pull out a negative 1, what you're left with in the parentheses is x minus 3. So you have this x minus 3 over x minus 3. They divide out. These are common factors that divide. So you're left with 1 over negative 1, which simplifies to 1 right there. So this explanation is what this example right here is showing you. And we're going to see one example in the next slide that shows you doing that, working with this. So here with example 3, we're going to simplify these rational expressions if it's possible. So the first step for A here, we have b squared minus 25 and b squared plus 10b plus 25. So what we're going to do is we're going to factor out both the numerator and the denominator if it's possible. And for this situation, it is possible. So when we factor out b squared minus 25, that's b minus 5 and b plus 5. And then for the denominator, we factor that out and get b plus 5 and b plus 5. So then what we do is we divide out common factors, which is going to be this b plus 5 right here. So what I'm going to be left with is b over 5 equals b plus 5. And then we set our denominator equal to 0 to see if there's any excluded values. So when we set b plus 5 equal to 0, and we subtract 5 to both sides, b cannot equal 5 here for this. So this is going to be my final answer right here for A. The next one, we're going to factor out the numerator and denominator. So what goes into 5x minus 10? 5 goes into both 5 and 10, so we factor out a 5 and get x minus 2 over, then we factor out what we have in common for the denominator, which is 4 minus x squared. So how can we factor that out? You're going to get 2 minus x and 2 plus x. Notice that they're putting the value before the variable for the denominator. We're used to seeing it as x maybe minus 2 and x plus 2, but notice here they have the number first. So it's going to be 2 minus x, 2 plus x. This is where we're running into the opposite binomials here. So what we're going to do is we identify our opposite binomials. And so my opposite binomials are going to be this x minus 2 and 2 minus x. So we're going to rewrite one of the opposite binomials. And I'm going to rewrite the bottom one, so I'll pull out a negative 1. And when I rewrite that, we have 5 parentheses x minus 2 as the numerator. And we pull out this negative 1, so we get x minus 2 for the denominator and 2 plus x. These x minus 2 will cancel. So we divided out the factors, and now we're just going to simplify this down. So when we simplify this down, we are going to end up with 5 over 2 plus x, and you just pull out the negative in front. The negative could be connected with the 5 or the 2 plus x, either one, but this will be my final answer here for B.